8.1G. If you were to repeatedly simple random sample a group of 10, n equals 10 salmon, the middle 60% of the time their mean length would be between blank and blank. So the same mu and sigma from the top of the page. So we're looking for two answers. Okay, so now we're going to be using a new function, inverse norm. So notice that in question G and H, they give us a percentage. So now we need to play the game backwards. So when you play a game backwards in math, it's called an inverse. So A through F, we kept using, what do we keep using? Normal CDF. Now that we're playing the game backwards, they give us the percent. We need to find the lengths. That is going to require the inverse norm. And the inverse norm requires an area, comma, a mu, comma, and a new sigma. Now, again, I have my old calculator. I have to memorize that. I'll write this down on your next test, whenever that is. Some of you have the fancy calculator, and it straight up asks you in 3 rows really explicitly, hey, what's the area? Hey, what's the mu? Hey, what's the sigma? But some of us have older versions of the TI-8384, so we're going to have to enter it like that. Okay, so, thinking caps on. This one's going to take a picture. So let me first start by saying, okay, middle 60%. So let me draw a picture of the middle 60%, bell curve, 60% in the middle. So if there's 60% in the middle, then that means there is, let's see, that's 40% left over, but I got to put some on this side, some on that side. So that's 20% here and 20% here. Okay, so far so good. So I need to find that first location. So the area, our inverse norm is a left tail. So coming from the left this way, you see how we've gone through 20%? So the area, 20%, 0.20. The mu is 20. And then the sigma is our new sigma. Remember to divide sigma by square root of n. So 4 over root 10. So you see it asks for middle 60%, but I had to draw a picture in order to get that 0.20 here. So now to get this next location, remember the inverse norm is left tail. So how much area do I actually travel through? I travel through the 20% and the 60%. So this would be 80%. So right now you need to make sure that this makes sense. I think that makes sense. And then make sure this makes sense. So they're asking for the middle 60%, but you're going to end up putting 0.20 and 0.80 because you drew a picture. So that's the tricky part. And then the center, the mu is 20. The standard deviation is 4 over root 10. Okay, so now I just need to plug it into my calculator. Slide this over a little bit. Bring this over here. Oakley dokley. On. Okay, inverse norm, so second distribution. So right below the normal CDF, you see inverse norm. Okay, so the first one, to give it a 0.20, 0.2, 0.20, same thing, comma, 20, comma, 4 divided by root 10. 4 divided by square root 10, slide out, and parenthesis, enter. Can't read that very well. 18.935. So this first one gives me 18.935. I rounded to the third place for no reason whatsoever, just because I ran out of room. Okay, and then the next one, so same game. So distribution, right below normal CDF is inverse norm. Enter 0.80, 0.8, same thing. Does that make sense yet? Yeah, you drew a picture, makes sense, excellent. Comma, the mu of 20, comma, new standard deviation is 4 divided by square root of 10, slide out, end parenthesis, enter, and that gives us 21.065 when I round it correctly, equals 21.065. And I just rounded to the third place correctly for no particular reason. I'll pretend someone told me to round correctly to 3 places. Okay, so hopefully this picture makes sense. Why 0.20? Because inverse norm is a left tail. To get to this location, I went through 20%. And inverse norm is a left tail. How do I get to this location? I went through the 20% plus the 60%, so I went through 80%. And let's pretend that makes sense. One more, all right.